Hi future doctors, welcome to the next class. We were discussing about motional EMF. Now, if a conductor is going to be rotating in uniform magnetic field, then how much induced EMF is going to be developed between the ends of the rod. So, this is going to be length of the rod. So, now this rod is going to be rotating like this. So whenever it is rotating within this circular path, its flux is going to be changed. Whenever it is going to make some amount of angle, the amount of field lines will be passing through this is going to be changed. At the time, induced EMF will be developed between two ends of the rod, A and B. So otherwise X and Y you can take, because B is nothing but magnetic field here. Now, what is the induced EMF will be developed? So, in this, we can calculate in two ways. So, in this small portion, we are going to take, this is going to be dx. It is at a distance x. Now, it is rotating with velocity v means angular velocity. V is going to be r omega. That is nothing but v is going to be L omega. But this point where we are taking at a distance x, therefore v is equal to x omega we are going to take. Understood? Next, induced EMF formula. Whenever a conductor is going to be rotating, either linear velocity or angular velocity, E is equal to, we wrote this formula. So, from this formula, how we are going to write means, for this dx, small amount of dx, induced EMF, small de we are going to take. So, V, what is the length of this one we have taken? Dx. So, whenever at x length, if this dx is going to be taken at x length, then V can be written as like this. V is equal to x omega, because this x and V both are perpendicular. We can write like this into dx. This is dE. Both sides you can do integration. Integral dx is nothing but x, integral e is nothing but e. So b omega is constant, integral x dx. This x is changing from 0 to n. So 0 to n. So b omega x square by 2 between the limits 0 to L, that is of b omega L square. This is the induced EMF formula. Another way also you can do, area of this is going to be changing with respect to time. So area according to mathematics of r square theta. So flux is changing, E is equal to d phi by dt. So d by dt of, so half r square theta into b, because phi we came to know ba cos theta. Area of this one, away magnetic field is into, so minus minus will be cancelled. Now this one can be written as half, r is nothing but here total length, L square d theta by dt into b. So d theta by dt, rate of change of angular velocity of b omega L square. D theta by dt is nothing but omega. So here, then derivation, you have to remember this formula, very important. So why we gave derivation means, sometimes we have to apply this equation for the problems, little bit difficult problems. Those we will see later upcoming classes. So here we are learning all basic concepts to apply for the given problems. E is equal to half b omega L square. Now induced EMF is coming. Okay. Then what is the direction of the current? Which is positive terminal, negative terminal. In previous class we discussed, if L length, if it is moving with V velocity into the magnetic field. So we have given by taking the direction of current, positive and negative. In this, which is fixed end, blindly we can follow, which is fixed end, that is always positive, which is rotating, that is always negative. So this is going to be x and y, length L. It is rotating in magnetic field like this. So at the time, this is going to be rotating on a rim, negative end, this is going to be positive end. So positive and negative end means it will be coming E like this, isn't it? this is going to be the right. Now, what is the EMF formula means of B omega L square. So, same formula can be applied for disk also. A disk of radius r is going to be rotating in magnetic field. Then what is the induced EMF between two ends, center to end of B omega? In place of L, you have to write R square. So, just in place of L, if you replace R, you will get induced EMF developed between center and one end. Next, in a cycle wheel, this is a cycle wheel, spokes are going to be present. Each length is L. So many will be there. So here you can count how many are there. Okay. So 1, 2, 3, 4, 5, 6 I am taking. You can take two more, 7, 8. Like this. How many are going to take? So this is rotating in magnetic field. Then what is the induced EMF between center O and end A? We are going to ask. So now only we discussed if it is going to be rotating only for OA, how much induced EMF is going to be developed means O to A of B omega L square. If it is rotating with angular velocity, if it is rotating with angular velocity omega of B omega L square. Now, which is rotating end, that is going to become always negative. This is going to become positive. For all these, it will be same only. Then, how we are going to represent this E is equal to of B omega L square in this. So, for this, it is going to become like this. This is positive terminal, this is going to be negative terminal E. So, for all the lengths, spokes, so it is going to be same on. It will be coming like this. So, this is positive, this is negative, positive, negative. So, positive, negative, positive, negative, positive, negative. So, which is fixed and positive, which is rotating and negative. Now, see all these cells, how these are going to be connected. In current LCT, we discussed all positive ends connected to one point, all negative ends connected to one point. Therefore, all these connected in parallel. In parallel combination, what is the effective EMF means? E equivalent is going to be equal to E. If all are similar EMFs, effective EMF is going to be E if all are same. So, according to that, so between O and A, what is the effective EMF means? E, that is going to be of B omega L square. So, like this they are going to ask at the time, this is the formula you have to apply. B they will give, omega they will give, L value they will give. Next, same thing. So, they are asking. So, A or P and Q you can take, B we will take magnetic field. So, PQ is a conductor of length L, total length. So, what is the effective EMF if it is rotating in uniform magnetic field? In uniform magnetic field B between P and Q, induced EMF between P and Q, between O and Q, between O and P they are going to ask. If total length is L, O to P length is L by 2, O to Q length is L by 2, L by 2. Total length is going to be L. Now, it is rotating with angular velocity omega. Like this, it is going to be rotating. So, whenever it is rotating from O to Q, so Q is rotating end negative, O is fixed end positive. Here also same fixed and positive, rotating and negative. So, O is fixed and positive. This is going to be negative. Therefore, between O and Q, what is the effective EMF means? Of B omega. What is the length of OQ? That is going to be L by 2 whole square. So, 2 square means 4, 4 into 2, 8. So, 1 by 8 B omega L square. Next, O2P. O2P also same length of B omega L by 2 whole square of B omega L square by 4. So 1 by 8 B omega L square between O2P also. Isn't it? Now what is the EMF between P2Q? PQ. That is effective EMF. Effective EMF means how we are going to calculate means whenever it is rotating like this, we said this is negative and positive. Now you can apply battery for this. How we are going to apply battery means positive end. This is positive end, this is negative end. This is positive end, this is negative end. See, between P and Q, effective EMF, if two cells connected like this, E, E. Positive is connected with positive. That is wrongly connected cell. In current density we discussed. Therefore, E minus E. That is going to become 0. Effective EMF between P and Q for this case is going to become 0. Between O and Q, this one. O and Q, O and P, effective EMF. How you have to do? By applying formula of B omega L square. So, like this, if you remember, just one formula we applied so many times. So, blindly we can follow which is rotating, that end is going to become negative, which is fixed, that end is going to become positive. So, you can practice. Thank you.